In this video, I'm going to show you how we can find integral of sine and cosine functions with odd or even degrees. Let us start with this example, integral of cosine to the 3x dx. The method for finding integral of cosine or sine with odd degrees is to separate one cosine or sine depending on the question. Always, it doesn't matter what is the power. As long as the power is odd, 3, 5, 7 and so on, separate one cosine or sine, like here, cosine to the 3x can be written as cosine x times by cosine to the 2x. If it was cosine to the, let's say, 9x dx, then we write this as cosine x times cosine to the 8x. So, whenever we have odd power, we save one factor of cosine or sine, we separate that, we leave it aside like here, and then for the remaining part, for this part, we use these identities depending to the question. Remember from trigonometric identities, cosine to the 2x is 1 minus sine squared, and sine squared is 1 minus cosine squared. Here, because we have cosine to the 2x, we are going to use this identity. Basically, the idea is to rewrite this part in terms of sine. But why we are doing this? Because remember, we want to do a substitution. And because the derivative of sine is cosine, so we want to write this part in terms of sine. And then by choosing sine as u, we have derivative of u here, and then we can find the integral. So let's continue finding this integral. So now we keep the cosine x here, and 1 cosine to the 2 is 1 minus sine squared x dx. Now here we do a simple substitution. We suppose u to be equal to sine x. Why we do this substitution? Because attention again, when we choose u as sine x, derivative of this u is exactly here. So we choose u as sine x, and then du would be cosine x dx. Solve this for dx as usual. If we solve this for dx, dx is du over cosine x. And attention again, cosine x is exactly here. So, if we continue this, we have integral cosine x times by 1 minus sine x is u, so u to the 2 times dx. What is dx? dx is du over cosine x. Now cosine x from denominator with cosine x from numerator cancels, and then we have only 1 minus u to the 2 du. What is the integral of 1? Don't make this mistake. Integral of 1 is not always x. Depends to the differential that we have here, because we have 1 du, so integral of 1 is u, and integral of u to the 2 based on the power rule is u to the 3 over 3 plus c. And remember, u was sine x, so the integral is sine x minus sine to the 3x over 3 plus c. So let's review the process of finding integral of sine or cosine functions with odd degrees. Always, we save a factor of sine or cosine depending to the function that here we have. We separate this, and then for the rest, whatever remains here, we use one of these identities to write cosine or sine in terms of the other function. And then we choose whatever is here, not the power, just the function sine x or cosine x as u, and then we do u substitution. So, I have written the process for you here. In general, for finding integral of sine or cosine with odd powers, if the degree of the sine is odd, say 1 sine, and use this identity. And if the power of cosine is odd, say 1 cosine, like the previous question that we had, and use this identity similar to the previous question that we did together, and rewrite the terms in terms of sine, and at the end choose u as sine of x, exactly similar to the previous question that we did here. Now look at this example. We want to find integral of sine to the 5x cosine to the 4. Here cosine is with even degree, but sine is with odd degree. So whenever we have a sine with odd degree, save one sign. So here, for doing this question, we write sine x, we save this here as a factor, and sine to the 5 would be sine to the 4. We have one sine here times by sine to the 4, in total would be sine to the 5. And we leave cosine to the 4 here. Now, we use this relation to write sine in terms of cosine. So let me erase here. Now we want to write this sine to the 4 in terms of cosine. Sine to the 4 is basically sine to the 2x all to the 2. So here we can write this as sine x times by sine to the 2x all to the 2 times cosine to the 4x dx. Now we can use this identity and we can write sine to the 2 in terms of cosine to the 2. So this equals to integral sine x times by 1 minus cosine to the 2 all to the 2 times by cosine to the 4 dx. And after this substitution, what we have to do? And then substitute, use this substitution. U is cosine x. So now for finding this integral, we suppose u cosine x, then du is negative sine x dx. If we solve this for dx, dx is du over negative sine x. If we do the substitution, if we apply the substitution now, then we have integral. This integral is equal to, we leave the sine x, it cancels in a moment. Then attention, cosine x is u, so whenever you see cosine, replace it with u. So 1 minus u to the 2 times by cosine to the 4 is u to the 4. But what dx? Dx is, look at here, dx is du over negative sine x. Now sine x with sine x cancels. So what we have after? If we cancel sine x with sine x, and attention, we can move this negative to the outside of the integral. So this equals to negative integral 1 minus u squared to the 2 times u to the 4 du. For finding this integral, first we have to raise the bracket to the power of 2. We have to open this bracket. 1 minus u squared to the 2 is 1 minus u squared times 1 minus u squared. If you know the identity for raising to the 2, you can use that identity. But if you don't know the identity for raising this bracket to the power of 2, simply multiply the bracket by each other. 1 times 1 is 1 minus u2 minus u2 plus u to the 4. So this equals u to the 4 minus 2u2 plus 1. So we have minus integral u to the 4 minus 2u to the 2, u to the 2 plus 1 times u to the 4 du. Now if we multiply u to the 4 in the bracket, we have a negative here. Then we have u to the 8 minus 2u to the 6 plus u to the 4 du. this integral is equal to negative u to the 8 is u to the 9 over 9 based on the power minus 2 times u to the 7 over 7 plus u to the 5 over 5 plus c. But remember, u is cosine x. So the final answer for this question is negative cosine to the 9x over 9 minus 2 cosine to the 7x over 7 and plus cosine to the 5x over 5 plus c. And this x should be written here. And this is the answer of this integral. So whenever we have sine and cosine with odd degrees, we separate one sine and cosine, and then we use one of these identities depending to the question to write cosine or sine in terms of the other function, and then we choose sine or cosine as u. What if we have a question that we have sine and cosine, both of them have odd degrees? Here it's completely up to you. You can save one sine or you can save one cosine. It's not important which one to choose, and separate and save one factor of that for yourself. Here you can simply write this as sine x times sine s squared, and then replace this with 1 minus cosine s squared. Or the other option that you can do this question is simply write this as cosine x times cosine s squared, and then write this as 1 minus sine s squared. Because here you have cosine, you saved one cosine, you are going to choose sine x as u, and this would be your du. So both of them works for you. It's completely up to you, and it doesn't matter really which one to choose. So here I am going to write to save one cosine. So basically we leave sine to the 3x here, and we write cosine to the 3 as cosine to the 2x times cosine x dx. Now because we saved one cosine here, we have to write this part in terms of sine. So cosine to the 2 is 1 minus sine to the 2. So this equals to integral sine to the 3x times by 1 minus sine to the 2x times cosine x dx. Now we choose u as sine x because derivative of u is cosine x, and exactly we have cosine x here. If you want, you can solve this for dx as usual, or basically simply you can replace all of this with du and replace these terms with u. But because usually we prefer to solve this for dx, let's solve this for dx. Then dx is du over cosine x. So after this we have integral sine is u, so u to the 3 times by 1 minus sine to the 2 is 1 minus u to the 2 times cosine x, and dx is du over cosine. Finally cosine from numerator with denominator cancels, and we have u to the 3 minus u to the 5 du. We multiplied u to the 3 in the bracket, and then we have u to the 3 minus u to the 5. Integral of u to the 3 is u to the 4 over 4. So this equals u to the 4 over 4 minus u to the 6 over 6 plus c. But what is u? U is sine x, so sine to the 4x over 4 minus sine to the 6x over 6 plus c. Now let's see what we have to do if we have sine and cosine and none of them is with odd degree, and both of them are even degree. For example, how we can find integral of sine to the 2 or sine to the 4 or cosine to the 2? If both of sine and cosine in the question are with even degrees, we have to find a way to convert them and write them in terms of odd degrees. How we can do that? Simply, we have to use these two famous identities. Sine to the 2x is 1/2 1 minus cosine 2x, and cosine to the 2 is 1/2 1 plus cosine 2x. Attention, in the left side of these identities, the sine and cosine are with even degrees, which we don't like. So with the aim of these identities, now if we look at the right side, on the right side we have a cosine with power 1, and the power is odd, and we are happy to see power odd. So here, for finding integral of sine to the 2, we use this first identity, 1/2 1 minus cosine 2x. So this equals to integral of 1/2 1 minus cosine 2x dx. It's better to keep the 1/2 outside. Then we have 1 minus cosine 2x dx. And this equals 1/2. Integral of 1 is x. Integral of cosine 2x is 1/2 sine 2x and plus c. Let me explain you why integral of cosine 2x is 1/2 sine of 2x. Let me explain this in detail for you, and you can use this for other cases also. Whenever we have integral of sine or cosine, and instead of x we have a coefficient for x, let's say we have integral of, for example, like here, cosine of 2x. If you want to find this integral, you can say, okay, we choose this as u, to use u substitution. But it takes time. We prefer to find these type of simple integrals very fast. Remember, what was integral of cosine? Integral of cosine is sine. So, the answer is sine of 2x. Always the reciprocal of this coefficient you have to put here. And the reason for that is that based on the chain rule, if we take derivative of this, we have to back to this. But derivative of sine is cosine, yes. But we know that we have to take derivative of inside. And what is derivative of inside? Derivative of 2x is 2. So when we take derivative of this, we get an extra 2 here. But we want to get just cosine. So we have to put the reciprocal of the coefficient of x here. So because of the chain rule, we want to apply the opposite of the chain rule here. So always reciprocal of coefficient of x we have to multiply by the answer. So this equals 1/2 sine of 2x. What about the integral of cosine, let's say pi x dx? The answer is 1/pi sine of pi x plus c. What is integral of e to the 3x dx? We know that integral of e to the x is e to the x, so integral of e to the 3x should be e to the 3x. Reciprocal of the coefficient here. You don't need to waste your time choosing this as u substitution and so on. No. Always take the integral with the formula, reciprocal of the coefficient. Attention, it should be only a coefficient for x, then reciprocal goes. And you have to multiply your answer by the reciprocal of the coefficient. Another example, what about integral of something like sine of 7x dx? We remember integral of sine x is negative cosine x, because here is 7x, so negative cosine 7x. What number we have to multiply? 1/7. Attention, this negative is because of the formula of integral of sine. Integral of sine is negative cosine. And because here we have 7x, we have to put the reciprocal of 7 here. Now that we know this, you should understand why we can write this right away in this form. Integral of cosine is 1/2 sine of 2x. And if you want, you can multiply the 1/2 in the bracket and write your final answer here in the form of 1/2 x minus 1/4 sine of 2x plus c. What about the integral of sine to the 4x? Again, we have a trig function with even degree. We don't have any odd degree. So again, we remember that sine to the 2x is 1/2 1 minus cosine 2x. Why we use this relation? Because we want to convert even degree to odd degree. But here is sine to the 4. It's not sine to the 2. Then we can write this as sine to the 2 to the 2. And now for the bracket, we can use this relation. So we replace inside the bracket with 1/2 1 times 1 minus cosine. So 1/2 times 1 minus cosine 2x should raise to the 2. 1/2 to the power of 2 is 1/4. And it's good idea to put it outside of the integral. 1/4 integral of. Now we have to raise the bracket to the power of 2. 1 minus cosine 2x to the power of 2 is 1 minus 2 cosine 2x plus cosine squared 2x. The reason is that if you multiply 1 minus cosine 2x by 1 minus cosine 2x term by term, 1 times 1 would be this term, 1 times cosine, and negative cosine times 1 would give you this term, and cosine times cosine, you have this term. Now we have to integrate the expression in the bracket, but we notice that we can integrate this easily. We can integrate this also, but here we have again a trig function with even degree, and we don't like even degrees. We hate even degrees for integration of trig, sine and cosine functions. So again, we think to using half angle identities. Let me remind you, for cosine also we have similar relation. Cosine to the 2x is 1/2 1 plus cosine 2x. But this is not cosine to the 2x. This is cosine to the 2 of 2x. So for cosine squared of 2x, it equals 1/2 1 plus cosine of. Look at the relation. Whenever here you have x, the other side is 2x. So if here is a, the other side is 2a. If here is 5t, the other side is 10t. Whatever is here is double of this. So if here is 2x, the other side is 4x. So cosine to the 2 of 2x is 1/2 1 plus cosine of 4x. Now we can write this as 1/4 integral of 1 minus 2 cosine of 2x plus 1/2 times 1 plus cosine of 4x dx. Now all the terms in the bracket, we can find the integral easily. But before that, it's not bad idea to multiply 1/2 in the bracket and then add this 1/2 to 1 and then find the integrals. So I prefer to first multiply the 1/2 in the bracket. So we have 1. 1/2 times 1 is 1/2. 1/2 plus that 1 in the here would be 1 plus 1/2, which is 3/2. And then we have negative 2 cosine 2x, and also we have 1/2 cosine of 4x dx. Now we can find integral of all the terms in the bracket. This equals to 1/4. Integral of 3/2 is 3/2x. Integral of cosine 2x, remember the method that we learned. Integral of cosine 2x is 1/2 sine of 2x. So this equals to minus 2 times 1/2 sine of 2x. And of course you can simplify 2 with 1/2 and write it just as negative sine of 2x. What about the next term? 1/2, we leave it here. Integral of cosine 4x is 1/4 sine of 4x. So if we want, we can multiply the 1/4 in the bracket, and then we have 3/8x this cancels with this, and then we have 1/4 of sine of 2x minus 1/4 of sine of 2x. 1/4 times by 1/8, which is have here, would be 1/32 sine of 4x plus c. So whenever we have sine or cosine with even degrees, we use half angle identities to make the powers odd, and then we start integrating trig functions with odd degrees. And if during this process we get again another trig function with odd degrees, again we have to use these half angle identities to get to the odd powers. Now look at this example. Integral from 0 to pi over 2 of sine to the 2x cosine to the 2. Here we have a sine, but the power is even, cosine with even degree. So we don't like the even degrees. So here we think to changing these powers. Again, remember sine to the 2 is 1/2 1 minus cosine 2x. Cosine to the 2 is 1/2 1 plus cosine 2x. So simply here we can replace sine to the 2 with this and cosine to the 2 with that. So we have integral from 0 to pi over 2. Sine to the 2 we replace with this 1/2 1 minus cosine 2x. And for cosine to the 2, 1/2 1 plus cosine 2x dx. 1/2 times 1/2 is 1/4, and we can leave it outside. So 1/4 integral 0 to pi over 2. If you multiply these two brackets by each other, if you pay attention, this is like a minus b, and this is like a plus b. A minus b times a plus b is a to the 2 minus b to the 2. So when we multiply these two brackets by each other, then we have 1 to the 2, which is 1 minus cosine to the 2 of 2x. And now we have another trig function, cosine of 2x, but the power is even. So what we have to do? We use the identities again to make the power odd, to get rid of the power 2. Because cosine to the 2x is 1/2 of 1 plus cosine 2x, so cosine to the 2 of 2x would be 1/2 of 1 plus cosine of 4x. The angle here in the other side is doubled, so if here is 2x, the other side is 4x. So here we have 1/4 integral from 0 to pi over 2 of 1 minus 1/2 1 plus cosine of 4x dx. Multiply 1/2 in the bracket. Then we have minus 1/2 minus 1/2 cosine of 4x. So this equals to 1/4 integral from 0 to pi over 2. 1 minus 1/2 minus 1/2 cosine 4x. 1 minus 1/2 is 1/2. So we can write this as 1/2 minus 1/2 cosine of 4x dx. Integral of 1/2 is 1/2 x, and integral of 1/2 cosine of 4x is 1/2 times 1/4 sine of 4x, which this can be written as 1/8 sine of 4x. 1/8 sine of 4x from 0 to pi over 2. First we plug in pi over 2. If we plug in pi over 2 here, we have pi over 2 times by 1/2, which is pi over 4. If we multiply that 1/4 by that, it would be pi over 16. If we plug in pi over 4 here, pi over 2 here, pi over 2 times 4 is 2 pi. Sine of 2 pi is like sine of 0. Remember, 2 pi is here, is like 0. Sine of 0 is 0. So, when we plug in pi over 2, we get 0. Now we have to plug in 0. Yeah, and we have to subtract. But when we plug in 0, 1/2 x would be 0 because 1/2 times 0 is 0. And sine of 0 is also 0. So the final answer is pi over 16. This is the answer of this integral. Now look at this question. Maybe you wonder why I have included this example here. This is tangent. But attention, tangent is related to sine and cosine. We remember that. Tangent of x is basically sine of x over cosine x. So here simply, immediately we can write this as integral of sine to the 2 over cosine to the 2 times by cosine to the 3x dx. Now we can simplify cosine to the 3 with cosine to the 2 from denominator, cosine to the 2 with cosine to the 2 from numerator cancelled, and 1 cosine in numerator remains. So this equals to integral of sine to the 2x times cosine x dx. When we look at this one is with even degree, but we have a good news here, that this cosine is with power 1. And when we have a trig function with power odd power, we always say one factor of that power odd. And because here it's just cosine to the 1, it is just cosine to the 1 and we don't need to separate anything from that. But if it was something like cosine to the 3 or cosine to the 5, we have to separate one from that. But this is just cosine x. So we keep this like that. And attention, you don't need to write this with the half angle identities like 1/2, 1 minus cosine 2x. No. Remember, when we started this video, we talked about odd degrees. When we have trig function with odd degrees, never we think to using half angle identities. These are really easy examples. When we have this, we save one cosine or one sine, which we have here, and then we choose the other part as u. So here, for finding this integral, immediately we say u is sine x, and then du would be exactly this, cosine x. This is a simple substitution example. dx would be du over cosine x, and now we can do the substitution. So this integral equals to integral sine to the 2 is u to the 2 times cosine x times dx, which is du over cosine. Cosine with cosine cancels, and then we have integral of u to the 2 du. Integral of u to the 2 is u to the 3 over 3. But what was u? Remember, u is sine. U is sine of x. So this equals sine to the 3x over 3 plus c. So sometimes you need to use your knowledge from trig identities, trig relations. It's not only integration techniques that you need to know. You have to be good at algebra. You have to master algebra, trigonometric identities, these things, and of course you have to combine with integration methods. Then you can find these type of integrals. For example, when we face this question, we may think, okay, this is not related to sine and cosine. But as you can see, with a simple substitution, which was basically this relation, we write tangent as sine over cosine, and then we have a trig function with odd degree, and then we use that technique that we started with in this video. Now look at this example. Sine to the 2x, sine of 2x dx. The first thing that we notice in this question is that one of them is sine x, the other is sine of 2x. The angles are different, and in this case we cannot think to any of the methods that we have learned so far. The angles of sine and cosine should be the same. We don't know if the angles are different, what we have to do. So we have to convert them to each other. We have to make them the same. But how we can do that? Remember, we had an identity for sine of 2x, if you remember. Based on the double angle identities, if you remember, we can write sine of 2x as 2 sine x cosine x. So again, as you can see, this is not only an integration technique. You need to be good at trig identities, algebra. Then you have to combine those with integration methods. Then you can find integrals. So this equals to integral of sine to the 2 is sine to the 2. We leave sine to the 2 here. And sine 2x is 2 sine x cosine x dx. Now we can put the 2 outside. Then we have sine to the 3 times by cosine x dx. Now immediately we notice we have sine, we have cosine with odd degrees, and this is a good news. So it's up to you. You can here simply say this is sine times sine to the 2 and save one sine. So here you can do this sine times sine to the 2 and then write this as 1 minus cosine to the 2 and then choose the cosine as u. But the better way is to choose sine x as u and derivative of u is here. So both of the methods works, but whenever both of sine and cosine have odd degrees, it's better to work with the one that has a smaller power. Here sine is with power 3, but cosine is just with power 1, and exactly we need just one cosine, because that part, that cosine with power 1, plays the role of derivative of sine. So the better way for finding this integral is not to start with sine. So here immediately we say we don't need to do anything. Immediately we use sine x as u, and then du is cosine x, which is exactly. Then we do the substitution. So this equals to 2 integral sine is u, so u to the 3 times cosine x times dx. If we solve this for dx, dx is du over cosine, so du over cosine, cosine with cosine cancels, then we have 2 integral u to the 3 du, integral of u to the 3 is u to the 4. 2 from numerator with 4 from denominator cancelled, and then we have 1/2 u to the 4. But what was u? U is sine. And this is the answer. I hope by watching this video you have learned about finding integral of sine and cosine with odd and even degrees. If you like this video, please subscribe to my channel and see you in the next videos.